boy. Oh boy.
So let's prepare the speed controls. I'm actually going to decase mine. You don't have to do this. You don't have to rewire them like I do. But I wanted to go ahead and try to clean it up and make it as nice as possible. So I'm actually going to cut the shrink wrap off the speed control. And I'm going to remove all the wires. I'm going to struggle here for a second getting the connector apart. You got to lift up little tabs on the servo connector that releases the actual metal pin that's inside, and it never wants to work out right for me. I have a friend who is amazing at it. He like a split second he's got all three out. I struggle. It takes me 5-10 minutes to get one out. It's ridiculous, but what are you gonna do? Most of the time I end up just breaking them off, the little tabs. I just rip them off because I get frustrated. So I've purchased stock in servo ends. Finally, I get it off, and then we're gonna go ahead and unwrap it from the toroid core, the ferrite core, whatever you want to call it, because we're actually gonna remove the power and the ground wire, and we're just gonna leave the signal. We're gonna do that to 3 of the speed controls because we don't need the ground or the power from the UBEC. It's also going to allow us to simplify or reduce the amount of toroids that we actually need to run on the wires. So I'm just splitting that wide away from the power and the ground. And I got me a nice toasty soldering iron with a chisel tip running about 600 degrees Fahrenheit. This is kind of dangerous just because you got some surface mount resistors right next to it, but if you're careful and you give it a light tug as you're heating it up, it should come right off. And I'm just putting the very tip of the chisel on it. And just like this, just like that, it comes off and we're done. So I'm just left with a signal wire. These look hand soldered because some of the FETs on here are terrible. They're misaligned. It almost looks like cold joints on some of them. So you might want to inspect them carefully. And if you see something not to your liking, go ahead and fix it. I went ahead and pulled the heatsink off because it actually makes it easier to get these power and motor wires off. The heatsink absorbs a lot of heat, and until it absorbs the heat, your iron won't really melt the solder. And when I'm doing this, I crank the heat up on the soldering iron up to around 800 degrees. I know it may be too hot, but you need a lot of heat to get that solder to melt quick so you don't have to apply it for very long and then overheat the entire board. So to start, I go ahead and add a little fresh solder to the old joint just to get it to flow a little easier. I don't have any flux. I need to actually get some flux. That would make life much, much easier, but I'm a cheap bastard and haven't bought any. But I apply the heat, and I wait till it flows, and I move the wire trying to get it to pull off, and it does. It pops off. And most of them come off easy like this, but not all. Here I am. I'm fixing one of the FETs where it meets the board. It almost looked like it wasn't connected at all, so I went ahead and fixed the solder job up a little bit. Poor Chinese kids. You know, they can't do very well when they're in a hot-ass little hut eating chicken and rice. Well, they probably don't even get the chicken, they just get rice. Nothing mystical about this process. You just need to be careful that you don't hold the iron on too long and then overheat, because you'll actually start seeing some of the components, seeing the bubbling and wanting to let loose from the board if you hold the heat on too much. Then I like to touch the pads up. Oh, it's a little hot, but you gotta be careful. Don't put your hand on something that had just been soldered at 800 degrees because it will burn you. I inspect everything to a ridiculous amount, but I want to make sure stuff works when I'm done. I'm going to go ahead and pull the power wire, and the power to the battery and the ground to the battery. These didn't come off as easy for me. As you'll see, they fought me tooth and nail, but in the end I won. I'm not sure why, but maybe it's because I had a Dean connector on it. It had a better heat sink ability, so the heat was being drawn away from the tip faster than it would have been on the other side. I get nervous just because I'm applying so much heat. I saw some of the parts, some of the resistors bubbling, which means that the solder holding them on was starting to liquefy. But then I was like, F it, and I just held the iron on until it popped off. Right about now I'm thinking to myself, why did I even start this? Because if this one's going to be a bastard, then they're all going to be bastards. So we're going to give it a go on the ground wire. And I can already tell it's not wanting to accept the new solder very well, so it's going to be a fighter. But I just leave that iron on. Just let it eat. And then I give up and look at it and think to myself, I'm going to burn this speed control up before I get the wire off. So I'm giving it the old sidearm twister. I'm yanking on that black wire and it finally lets go. Happy about that. I want to go ahead and flash this one just to make sure it still works, because I applied a lot of heat and I'm fearing that I burn it up. So we're going to flash it. That's the USB ASP programmer. I've got a video on how to do this that goes into a little more detail, but I wanted to at least show the process as I'm doing it. I'm just pulling up the flashing program. I do this to every one after I pull the wires off, just to make sure it's, at least I didn't destroy the IC on it. Taking a minute here, I gotta find the file. It's a BS infet for these F30 amps, or these are F20s, but the F30 and the F20 both use the same BS infet firmware. And I put my little connector on and hold it, and then hit the old flash button. In just a few 8 seconds, it's done. And then go ahead and pull the rest of them apart. I'm not going to bore you with it, so I'm going to speed it up. Again, this isn't something you have to do, but in the end I think it turns out to be a pretty tight wiring job. I mean, it would be tighter if I used aluminum booms and could thread the wire through the boom, but it's not bad for what